Chapter 1.5 is analyzing graphs of functions. So our goals for the chapter are to use a vertical line test for functions, find the zeros of the functions, determine intervals on which functions are increasing or decreasing, determine the average rate of change of a function, and identify even and odd functions. So for example 1, we're going to find the domain and range of a function. So remember, domain has to do with our x values, and a range has to do with our y values. So we're looking at the domain of f. So domain are our x values, and you notice that's here. So our range is from -1 to 5. Okay, so notice that this is a bracket because it's included, it's a closed circle, as opposed to this side, which is an open circle. Okay, so there is a difference with that. So the function value is f of -1 and f of 2. So we're given that when the x value is -1, we need to find out what is that y value. So at -1, we get a +1, right? It's right here. Then at 2, +2, our y value is -3. Last, let's look at the range. The range has to do with our y values, and notice here. So what's the lowest to the highest? So our lowest y value is here, which is a -3, and it is a closed circle there, so it's included. And then the highest it gets is a +3, and again, a bracket. So we're going to try this example here. Use a graph of the function f to find the domain, the function values f of 0 and f of 3, and the range of f. So if you try this out, the domain is all real numbers x, except that x equals 3. X equals 3. It should be x equals -3. So the reason why that is because notice there is a hole here, so I can have everything except for that value. Then at f of 0, we have 3. Right? At 0, we have y is 3, and at 3, we have y is -6. The range is -infinity to 3, or if you're still getting used to it, y is less than or equal to 3. So let's look at vertical line test. A vertical line test for functions. A set of points in a coordinate plane is a graph of y as a function of f of x if and only if no vertical line intersects the graph at more than one point. So hopefully this should be a quick review. So we look at example A. If you do the vertical line test, you draw several lines. You notice that it intersects at 2 different spots. Whenever that happens, we know that this is not a function. Okay? And letter B, for example, we can draw several vertical lines, and it only intersects at one point, so therefore, yes, this is a function. And so you can go ahead and try C and D real quick. Okay, for C, you notice that yes, that is a function. And also for D, yes, that is also a function. They all pass the vertical line test. Let's find the zeros of a function. If a graph of a function of x has an x-intercept at a, 0, then a is a 0 of the function. So when we're finding the zeros of the function, we're trying to find the x-intercepts. So what we're going to do is what we did previously is you just set f of x equal to 0 and then solve it algebraically. So let me do the first example. This is 0 equals 3x squared plus x minus 10, and that is factorable. So 0 equals 3x times x, and that's going to be 3x minus 5 and x plus 2. So that is 6 minus 5 and -10. Okay, so if I multiply it through, I would get that answer back. So x equals -2 and x equals +5/3. So those are the zeros of the function. Letter B, we have g of x equals 10 minus x squared. So 0 equals the square root of 10 minus x squared. You can go ahead and square both sides. Squaring the 0 is just 0. So 0 equals 10 minus x squared. Let's add x squared to both sides. So x equals plus or minus square root of 10. So let's try h of t. So with h of t, we're going to do 0 equals 2t minus 3 over t plus 5. So if we multiply t plus 5 to both sides, notice that it's just going to cancel out, right? Because on the left side, that's 0, and so that takes care of the denominator. So 0 equals 2t minus 3, or 3 equals 2t, or t equals 3 halves. So go ahead and try these examples down here. Pause the video, and I'll have the answers for you when you come back. So if you tried these out, you would have gotten, for letter A, x is negative 8 and 3 halves. For B, t equals 25. And for C, x equals plus or minus square root of 2.